Well, hello, Algebra 2. Hope you guys are doing well today. Well, we're going to take a look at Poly1. We're calling it Poly1 now. I know it's kind of weird. We're doing Poly1 after we've done Poly4 and Poly3 and Poly2. It's okay. It's okay. It's a reorganization of what we're doing. The highlights that we're trying to do at the end, we're trying to take all the things that we've done and then sketch graphs and use these use the foundation that we've built to this point. So let's take a look here. This is Graphing Polynomials guided notes here. How can we use all the great knowledge we've gained to this point? We've already talked about how to add, subtract, and multiply polynomials. We've talked about how to factor polynomials. We've also talked about how to divide polynomials. And when we did some of that division, we were given factors or trying to find out if they were factors. And what does that mean exactly? How does that look in terms of something visual we can represent? So what we're going to do right now, we're going to take all this knowledge and we're going to kind of combine it together. We're going to start with our understanding of what's a polynomial, what's a factor, and what's a solution, or x-intercept, or root, or zero, however you want to think about this. All right. So if we have this polynomial, this is a trinomial, by the way, because there are three terms. If I've got this polynomial of x squared plus 6x plus 8 equals 0, I can factor this. I know that there's something that multiplies to 8 and adds to 6. My factors in this case would be x plus 2 times x plus 4 equals 0, with my factors being x plus 2 and x plus 4. And if I wanted to find the solutions, I take those factors individually or independently. Remember, factors are things multiplied together. So x plus 2, set that equal to 0 and solve. So x equals -2. I would do that with my other factor as well. X plus 4 equals 0. So x equals -4. So what we're trying to do right now is build a relationship between polynomials, factors, and our solutions slash roots slash zeros slash x-intercepts. That's what we're trying to build this between. Let's take a look at this other one. This next one, again, we're looking in columns right now, right? So in this column, I've been given a factor. And what I need to do is I need to find the solutions, but then also complete the table by finding the polynomial. Let's do the factors or the solutions first, right? We set these independently equal to 0, x equals 1, -2, and 3, right? X minus 1 equals 0, x equals 1. X plus 2 equals 0, x equals -2. X minus 3 equals 0, so x equals 3. Now what we have to do, though, is we have to do some multiplication. Think of it like this. I'm going to have to do either x minus 1 times x plus 2, then take that resulting polynomial and multiply it by x plus 3. Remember, it's not like x minus 1 times x plus 2 times x minus 3 and then x plus 2. It's not multiplying everything. Think of it as like 5 times 6 times 7. I'm going to multiply x minus 1 times x plus 2, then that result times x plus 3. Let's go ahead and do that first. I'm going to do x minus 1. Make this nice and big here. X minus 1 times x plus 2. And if I do that, I'll use the distributive method. I like to set it up like this here. And when I do that, I distribute through, I get x squared plus 2x minus x minus 2. So if I take that resulting polynomial, I ended up with combined like terms. I've got x squared plus x minus 2. And this is what I have to multiply by the last thing I've got. I have to multiply this by x minus 3. And if I do that, I'll do the distributive method again. I'll do it a little bit differently. I'll do x and -3, x squared plus x minus 2, x squared plus x minus 2. Build in some things here. My top one, I have x cubed plus x squared minus 2x, -3x squared minus 3x plus 6. And if I combine my like terms, I'm going to end up with my polynomial after I've multiplied those three binomials together. I end up with x cubed, and I've got minus 2x squared because I've got a positive x squared and a -3x squared, minus 5x plus 6. That is what I'm trying to get to. That is my polynomial when I multiply those three things at the bottom. That's my polynomial when I multiply those three things at the bottom. X cubed plus 2x squared minus 5x plus 6. Now, if I had given you this x cubed minus 2x squared minus 5x plus 6, we don't actually have a way. Factoring by grouping wouldn't have worked in this case. What I would have to do is I'd have to give you a factor, and then you'd have to do division. You could do synthetic or long division, and then you'll end up with the resulting trinomial to factor again. Or you could use the quadratic formula if we needed to. That's how you could get to your solutions, right? So that's something we're looking at here. What in this case, let's look at this next column. I've given you the solutions. X equals -4, right? So x equals -4. What we're trying to do again, we're trying to make this like, if I'm going up, I want something that equals 0. In order to do that, I would have to add 4, right? If my solution was x equals -4, the factor for that would be x plus 4. X plus 4. If I had x equals 1, the factor for that would be x minus 1 equals 0. X minus 1. If I have x minus 5, the factor for that, x equals 5, the factor for that would be x minus 5 equals 0. X minus 5, all that equals 0. And now what I'm going to do the same thing that I just did. I'm going to multiply these three binomials together. I would start with x plus 4 times x minus 1, then take that and multiply it by x minus 5. I'm going to tell you a little secret though. You can always tell right away what your first term and last term are going to be, right? What I'm going to do is I'm going to multiply, just out of curiosity, I'm going to multiply all the three first terms, x times x times x. I am betting, actually I know this already, but I am telling you that the first term will be x cubed. I know that's what's going to happen. All right, you can write it down somewhere if you don't believe me, but we'll get there. And my last term is going to be 4 times -1 times -5. Well, 4 times -1 is -4, and -4 times -5 is +20. So I'm telling you it's going to be x cubed and +20, and we just got to kind of figure out the middle. Now we're going to get to x cubed and 20 along the way too, but that's how we're going to start this business. We'll do the same thing we did over here. Let's see, maybe a different color will help out. Differentiate it between the last one here. So I'm going to do first x plus 4 times x minus 1. Now, and again, if you did this in a different order, like x minus 1 times the x minus 5 first, that's okay, remember, because it doesn't matter the order you multiply as long as you do all the multiplication correctly. So let's see, I've got x and 4, x minus 1. If I distribute through properly, I have x squared minus x, 4x minus 4, and I end up with x squared plus 3x minus 4. Hopefully also at this point, you're starting to see some shortcuts to how to get this. Hopefully you're starting to see that. Like if I'm looking at that one, 4 and -1 is -4, x and x is x squared. You'll have 4x and -x for plus 3x. Hopefully you're starting to see that. We still have to multiply this all by x minus 5. So let's do our distribution here. I know I'm kind of running out of room. That's all right. X and -5, x squared plus 3x minus 4. And here we got x squared plus 3x minus 4. We're going to distribute through again. I have x cubed. Hey, we said we were going to get that. Plus 3x squared minus 4x. Down here we have -5x squared minus 15x plus 20. Hey, told you, right? Those are the two things. Our first term is going to be x cubed. Got that. Last term is going to be +20. We got that. Let's see what we do end up with though. Overall, I have x cubed. My x squared terms, I have +3 and -5, so minus 2x squared. I have minus 19x. Then, oh, I'm going to have to rewrite this. Got a little excited about that one. X cubed minus 2x squared minus 19x plus 20. That is my polynomial. That's what I was trying to get to. And it looks like I nailed this thing. Which is a good thing because I'm trying to teach you, right? Those are the polynomials we're trying to get to. All right, so I'm going to do one more of these things here. I'm going to do one more, and then it's going to be your opportunity to do some on the bottom. Now, I'm going to give you some help, but I'm going to go through a couple of them with a little bit more detail. But what I want to point out here on this last one, we've got a double root. Well, what does a double root mean? Well, this means I could have also written this as x equals -1, -1, 3 and 4, 3 and 4. In other words, -1 happens twice. Now we're going to need that. We're going to need to know that. There's a reason I've written the double root part. So just remember, you've got the fact that there's a double root means that the value happens twice. Just kind of put that in your back pocket or your math toolbox or whatever you want to do that real quick. But what I need to do now is I need to have 2 of these x minus. So if x equals -1, x would equal, or x plus 1 would equal 0, and this happens twice. I could have like x plus 1 squared times x minus 3 times x minus 4 equals 0. Again, you could also rewrite this as x plus 1 times x plus 1 times x minus 3 times x minus 4 equals 0. Okay, either one of those is fine. Either one of those is fine. But the big idea, one of the big ideas, is you need to recognize that that -1 happens twice. That -1 happens twice. All right, so what I'm going to do is I'm going to make sure we know the first term. Well, I've got like x times x times x times x, or x squared times x times x. That first term will be x to the 4th. All right, x to the 4th. My last term, I've got 1 times 1 times -3 times -4. So this is going to end up being a positive 12. Now we can go ahead and do that multiplication. I'm not going to show you that multiplication this time. It's just taking it one more step than what we did in the last one. I'll end up with x to the 4th minus 5x cubed. Double checking my work here. Minus x squared plus 17x plus 12. That is what you should end up with. I would suggest that you try it. Maybe you have to do it on another sheet of paper, and that's okay. But that's what you should end up with for that polynomial. So now we've got these four polynomials, factor solutions, the set of data that we've worked with. What you need to do is take a look at this, right? Some of the big ideas: how do we turn factors into polynomials? How do we go from factoring to polynomial-ing, I guess? We multiply, right? We do polynomial multiplication. That's what we did, right? That was poly1, or sorry, poly2. Add, subtract, in, multiply. And that add and subtract, that comes in when you're kind of trying to combine like terms. All right. If you're trying to turn factors into solutions, so going from factors to solutions, you set each individual factor equal to 0 and solve. These I've made very nice for you. Maybe sometime you'll have to use the quadratic formula to get some other answers. They might not be whole numbers, or maybe imaginary solutions too, right? But we set those individual factors equal to 0 and solve. That's what we did right here. Now, sometimes if I'm trying to go from a polynomial to a factor, I may be able to use, again, polynomial to factor. If I'm trying to go this way, I may be able to use just straight factoring. I may also have to do some division. If you have to do division, I would give you one of the factors, so you could do your synthetic or long division, and then do some other math to find the rest of the factors. All right, that's how we do that one. All right, if it's synthetic division, remember, if the remainder is 0, it's a factor. That binomial is a factor. You have to either factor a quadratic formula to find additional solutions. For synthetic division, remember, if you do the synthetic division and that remainder is not 0, it's not actually a factor. So keep that in mind as you go through to check your work. Speaking of doing work, you're going to get to do this set right here. These 4 columns, I want you to do the same thing that we did up above. If I give you the polynomial like I've done here, I want you to find the factors and solutions. If I give you the factors, I want you to find the polynomial and solutions. If I give you the solutions, I want you to find the factors and the polynomial. Now, there's that double root again. That just applies to 1. And this 0 down here, that's just a plain x up here. That's going to be my hint. X times something, because if x was 0, 0 times all doesn't matter is going to give you 0. So that's my hint. What I want you guys to do, it's going to take a little bit of time, and that's okay. Try these out, come back and check your work. If you're not sure why you got something wrong, that's when you send me an email or you ask a question in class to me, myself, or Mr. Gubino. All right, give it a shot, come back and check your work. All right, as you return to check your work, I want you to especially pay close attention, well, to all of them, first of all, but to that last one especially, because if you notice that last one, my solutions were -2, 1, and 3. And what we're going to do is pretend like I did this on purpose to teach you a lesson on this one. So you'll notice that these are in a different order than the solutions that I gave you up above. And I think the very second one, 1, -2, and 3. -2, 1, and 3. So maybe that was my way. Let's pretend that we're going to pretend here that was my way of saying, see, it doesn't matter the order of multiplication. You'll still come up with the same thing. Hopefully that's what you came up with on that one there too. So yeah. All right. That's again, a good introduction to what we're trying to take care of. And we're getting now towards the graphing part of things. So let's go ahead, take a minute and move to the next page. Let's go to the top of page 2. Right now, you're also going to want to go to Desmos on this one. So I'm going to give you guys a chance real quick. I'm going to pause and let you go ahead and open up Desmos, maybe right beside it. Bring them both up if you're doing that, or a couple windows if you got a computer. But I'm going to hit pause, give you an opportunity to bring up Desmos also. All right, so hopefully you've had the opportunity to open up Desmos. I'm going to be hopping there in a second, but first, before I do that, I want to show you what I'm trying to do. We're going back to the beginning, back to end behavior. What happens at the end of functions? That's what we're trying to do, all right? What's happening at the end of functions? And what we're going to end up doing is, you'll see it in Desmos in a second, but what I want you guys to graph in Desmos, the first 4 graphs I want you to put up are x squared, x to the 4th, x to the 6th, and x to the 8th. You'll notice the what's interesting about those, they all have an even exponent, and they're all positive. They're all positive with even exponents. Okay, let's take a look at what that looks like. Positive with even exponents. So if you graph x squared, x to the 4th, x to the 6th, x to the 8th, I've got the other ones turned off right now. I know you can see this, right? If you look at these, all the end behaviors on the left side, those functions, those are pointing up. On the right side of the functions, they're also pointing up. Well, what's up? Not much. What's up with you? Hope I get a laugh out of that one. All right. But what happens is, on both sides of these functions, the end behavior is going to infinity as x goes to negative infinity, and it's going to positive infinity also as x goes to positive infinity. They're both going up. So if my end behavior has an even exponent and a positive a value is multiplied by a positive value, my end behavior is up and up. Now, what happens? Let's see, if I made these negative, what would happen? Hopefully you already got a pretty good idea, because this is part of that one of those first targets we did. I am just reflecting over the x-axis, and I hope you're noticing what's happening here. You should notice, as they reflect over the x-axis, that all the end behaviors are now down and down. Both are pointing down. The end behaviors are down and down. So let's go ahead and take a look at this. Let's go ahead and see what we got. Okay. Okay, so let's go back here. If I've got an even exponent and a positive a value, our end behavior was up on the left and up on the right. Then we noticed if we have a negative a value and an even exponent, we have down on the left and down on the right. Okay. So let's also take a look over here. What if I had x? Well, it's x to the 1st, then x cubed, x to the 5th, x to the 7th. They all have the same end behavior as well. So let's go ahead and take a look at these. If I have positive versions of those. So we're going to unhook these. We're going to turn these off here. These 4 off and turn these on. Hopefully you're noticing what's happening on the left. The end behavior on the left is they're going down. They're going down. What's down? I don't know what's down with you. It's down is negative infinity. So if the a value is positive and the exponent is odd, the left side goes down and the right side goes up to positive infinity. If I made these negative, it's going to do the same thing. It's going to flip. Put a negative here and a negative here and a negative here and one more negative right here. You'll notice that they've all flipped. If it's negative, if it's a negative coefficient and an odd exponent, now I've got up on the left, down on the right. So let's go ahead and fill out this little table here again. Let's make sure we're all on the same page on having this table filled out. Right? We just said with an odd exponent and a positive value, it was down on the left and up on the right. That's what the graphs look like. And if it was negative, it was flipped. It was up on the left and down on the right. Now, how are we going to use this? I'm glad you asked. We're going to get there, I promise. I promise we will get there. But first, what I want to make sure we can do is we can identify from a polynomial what our a value is, if it's positive or negative, and if I have an even or an odd exponent on my largest, my leading term. We've talked about this, right? In standard form, your leading term is the one with the biggest exponent. And that coefficient we call the leading coefficient. So right here, in the first one, my a value is -6 because it's multiplying x cubed, and cubed is my biggest exponent. My a value is -6 with an odd exponent. So let's see what that looks like. If I have a negative a value, so now I'm down in these two on the bottom, and if I have an odd exponent, that means my end behavior is up on the left and down on the right. So on the left side, it's going up. So as x goes to negative infinity, our f of x values go to positive infinity. And on the right, it goes down. So as x goes to positive infinity, f of x, my y values go to negative infinity. I can do better than that. It's even worse. There we go, to negative infinity. All right, that's what we're trying to do. I'm going to do one more example. This is in standard form. My biggest exponent is 4, so I have an even exponent. My coefficient is a positive 7. 7 is positive, so I have positive a, and I've got an even exponent, which means my end behavior goes up and up, up and up. So on the left side, if it goes up, that means it goes to positive infinity. On the right side, if it goes up, that means my y values also go to positive infinity. So with that said, what I need you guys to do is do the rest of this table. And I'm going to highlight this one right here. It's not in standard form. You might want to rewrite that to check that. All right. So I'm going to hit pause. You're going to hit pause or whatever we're doing, and you're going to try it on your own, then come back and check your work. All right, as you come back, go ahead and check your work here. Like I said, the one that might catch your attention is this one right here, because x to the 7th is actually the largest exponent. You'd have to rewrite this as -6x to the 7th plus x to the 5th minus 4x. Now it's still an odd exponent. It's still an odd exponent, but what happens is that makes your a value negative. So that changes things up a little bit. And if you were to go into Desmos and graph all of these, which you can, absolutely can, you would see that our end behaviors would match these things. So I've talked about as they go to what the y values do as the x values go to negative and positive infinities. I've also put the arrows, the end behaviors on the right. Those are going to be key. That's something we're going to be looking for here pretty quick. All right, we're almost there. We're getting closer. We're getting closer to our actual practice, what we're actually trying to do here. Now, I want to highlight a few things. Now, I know this is not the greatest and most clear figure in the entire world, but it gets the point across, and that's what I'm looking for. Remember earlier when I talked about double roots and things that only happen one time, you can consider that a single root. And also Triple roots, what happens 3 times if it was like x plus 1 cubed, right? We call those triple roots. So let's look right here. So I'm going to highlight this. Let's use a different color here. I'm going to use this one. Single roots, it just crosses through the x-axis. Notice how we've got some end behavior going on here. End behavior. We've got single roots cross, they just go through. Double roots, it just touches the x-axis. The word that I like to use is it bounces off the x-axis, a little bit of a bounce, right? We've got our y-intercept. That is where x equals 0, right? Where the value of x, or the value of the function when x is 0, still, yeah, don't look at that part, right? So our y-intercept. We've also got these maximums and minimums. Those are just we're sketching graphs. We're not trying to do perfect work. If you take higher level math, you'll do some of the, like, what are the maximums and minimums? We're not trying to do that. What we're trying to do is just find our y-intercept right now. There's also this triple root thing right here. This triple root. Notice how it does go through the x-axis, but it's got this little inflection. It's kind of like got this little curvature to it. All right, so remember that as we go through here, we've got single roots, double roots, triple roots, single and triple. So again, you know, if the exponent's 1, kind of, you can think of single, triple, 5, 7, they would go through. But if I've got an even number, like a double root, if it happens an even number of times, we've got a bounce. And we've also got this end behavior. We're going to talk about how to sketch these things. So let me give you a little example on what this looks like. I've got some information down here. I've already given you the end behavior. That's here and here. So it's left. On the left, it goes to positive infinity. On the right, it goes to negative infinity. I've got a single root. If it doesn't say it's a single root, by the way, that's what that is. I've got a double root. So we know it's going to bounce here. Let's start on the left, all right? We've got a single root. We know it's going to go through. Now I bring it back towards the x-axis, towards my next root. I've got this double root, and it's going to bounce off that double root and go down to negative infinity. All right, so we've got this local minimum. I have no idea if it's actually at -6. All I'm trying to do is do a little sketch to make it look like this, okay? When we do our practice, you'll notice the y-axis won't even have any y values. That's for you to work on, right? When we're trying to do y-intercepts. Here, I've got on the left, as x goes to negative infinity, f of x or my y values go to negative infinity. And on the right, it's positive infinity. This would be like an odd with a positive a value. I have no idea what it is. Well, we can take a look. I mean, we'll figure it out at some point, right? These are single roots with a triple root. I'm going to go through my single root, come back now down towards my triple root. Remember, this is going to go through, but it's got this little inflection thing going on. Go back towards the x-axis and then through another single root and out and out. So we've got sketches again. Remember, my maxes and mins, I'm not super worried about, all right? I'm just trying to get you to understand what we're trying to do there. All right, we'll figure out those later at a later time. Y-intercepts we will work with. So what I want you guys to do is using these concepts, this concept we've just talked about here, I want you to attempt to sketch on the next page, the top 2. I want you to do this on your own. Try to sketch these top 2. After you've sketched these top 2, come on back and check your work. All right, go ahead and check your work. What I want you to notice, and recognize is that between roots, you're going to bring your graph back towards the x-axis. But at the ends, towards the end behavior, you just go towards the end behavior. Okay, that's something to look at. Now, here's what you've all been waiting for. What am I actually trying to ask you? Here's some questions. These are some examples. It won't be everything that we do, but this is going to give you a really good start on what 1 and 2 level type questions look like and what 3 level type questions look like as well. So here's what we're going to start with right now. We're going to start with, what do we need to know? Number 1, determine the factors if necessary. This is more or less for the 3 level type questions, all right? Not for the 1 and 2. I'm going to give you what they are, give you the factors, give you in factored form essentially. You're going to have to determine the end behavior, determine the x-intercepts and zeros, determine the y-intercept, and sketch the polynomial. Remember, when you determine the y-intercept, we know the x value of the y-intercept, x is 0. Keep that in mind as we go through here. So let's take a look at this question. These are the 1 and 2 level. We're not going to have to do the determine the factors. We already have what we've got. I have 1, 2, 3, 4 x's, and I've got a leading negative. So this is going to act, this function is going to act like negative x to the 4th. Why do I put that in there? Why do I put that in there? Well, because I know this is going to have, it's a negative a value, and also an even exponent. Well, we know if you've got a negative a and an even exponent, our end behavior is down and down, which is interesting because I believe that's number 2. What's end behavior? 2, our end behavior is down and down. End behavior, our EB, is down and down. It'll be down on the left, down on the right, because we have a negative a and an even exponent. For number 3 asks us, I believe it's determine the values, right? I've got 4 factors here. I need to set each factor equal to 0 and solve. I'm going to do these one at a time here. I've got negative x equals 0. Well, this just means x equals 0. I've got x minus 4 equals 0, which means x equals 4. I've got x minus 3 equals 0, which means x equals 3. And I've got x plus 1 equals 0, which means x equals negative 1. These are my 4. You could have also listed them out as we get through these. On the next one, I'll go a little shorter with the descriptions, but I'm going to graph these. On the x-axis, these all, again, each graph is 1 unit, right? So I'm going to mark here. I've got 0, I've got 4, I've got 3, and I've got negative 1. So we're going to keep all these points in mind here. Determine the y-intercept. Well, this one's nice, all right? This question is nice because all I have to do is plug in 0 for every x that I see. Plug in 0 for every x that I see. So I have negative 0 times 0 minus 4 times 0 minus 3 times 0 plus 1. And what does that give us? Well, this is the nice part, right? We should be able to see it already on the graph. If I plug in 0, 0 times all this other stuff is going to give me 0. My y-intercept in this case is 0. So now we got to sketch this thing. We have our 4 points. These are all single roots. They're going to go through every time. My end behavior is down and down. So at my leftmost point, I've got a down. My rightmost point, I'm going to end up down. Remember, this is a function, so it can't break the vertical line test, right? I'm going to go through, and through. And notice that I've come back towards the x-axis every time. Do I have any idea what these y values are at the minimums and maximums? No. Do I need to know them right now? No. Could I figure them out? Yes, because they're halfway in between these things, but we don't need to worry about that right now. This is what you need to know. This is the sketch of this graph. That's the number 5 thing that you have to do. Again, there's no values on the y-axis because you can make your own. And I'm going to show you what that looks like on the next question, all right? Again, we didn't have to do number 1 here. We had to do 2 through 5. Let's look at our next question. Again, we have to, this one is just like the previous one in that we don't have to do the factoring. It's already done for us. So that we don't have to do number 1. Number 2 is end behavior. This is going to act like, well, let's see here. I've got x squared. So x squared times x, and both of these are positive. It's going to act like positive x cubed, which if I look back on my chart, that means on the left, I'll have down, and the right, I'll have up for my end behaviors. That's my end behavior, my EB. Number 3, we take our solutions, x minus 3 squared. Don't forget, this is like x minus 3 times x minus 3. then x plus 4 is still there. So I've got 3. So x minus 3 equals 0. So x equals 3. But that happens twice. What do we call that? We called that a double root. And hopefully you're doing, oh, I know something about the double root. Double. And then also -4. But at that double root, we know it's going to do what? Yeah, it's going to bounce off the x-axis. Not going to go through, but bounce. Number 4, we have to figure out our y-intercept. So we have to plug in 0 for x. So 0 minus 3 squared times 0 plus 4. Well, this gives us -3 squared times 4. -3 squared is 9, and 9 times 4 is 36. So our y-intercept is 36. So in other words, here's the thing. Wherever we get this to cross the y-axis, it's going to be 36, right? We also need to know this darn well better cross at a positive y. Let's check here. I've got x equals 3 to 3. That's a double root, and -4. 1, 2, 3, 4. With my end behavior, I've got down and up. Well, this one is going to be this -4. That's a single root. So I'm going to come up through, taking a little bit of time, up through, come back towards my x-axis, and then, oh, what's going to happen? Oh, this is interesting. It's going to bounce because this is a double root. Bounces off. I'll just make my own here. Bounces off and goes to positive infinity. Remember that double root bounces. So that's exactly what we made it do. That's exactly what we made it do. I love this right here. Single root, double root, and then right here, this value, that's 36. You know why? Because we said so. Why not? We said so. I have no idea if that's even really how it looks, but I know that the y-axis, it crosses at 36. All right, I've done 2, which means you get an opportunity to do one of these things. Take what you've learned in the last 2, try it out, come back, and check your work. All right, now that you're back, let's go ahead and check our work. We've got a triple root on that first one, x minus 1 cubed times x plus 3 times x minus 2. If we add those things up, we end up with an x to the 5th and a positive x to the 5th. So we've got down on the left, up on the right for our end behavior. We've got x equals 1 is a triple root because it happens 3 times. That's what cubed means. We've also got x plus 3, so x equals -3, and x equals 2. So I've laid out those points. My y-intercept ends up being 6 as I multiply through. I've got -1 cubed, which is -1, times 3 times -2. Gives me a positive 6, and that makes sense over here. I came through my single root of -3. I did my little inflection of my triple root at 1, and I did my coming back through my single root at 2. Matches my end behavior, exactly what I'm going for. All right, I'm feeling good about this. Now, we've done the 1 and 2 level. So what does the 3 type level look like? Well, the 3 type level looks like this. It's an example of one. Oh, here we go. I've got x cubed plus 6x squared plus 12x plus 8, where x plus 2 is a factor. In other words, I haven't given you this in factored form. We have to do factored form, but I've already given you one. This looks a lot like poly4, our dividing polynomial. So maybe that's what we should rock with, right? Let's use the dividing polynomial. And this is just this binomial right here. The way this works, I can use synthetic division, and so I will. So let's do it. X plus 2 is a factor, so I'm going to put -2 in the house, right? And I've got all my coefficients are there. I've got 1, 6, 12, and 8, so I don't have to do anything with having a 0 in there. Set my stuff up here. Since we know x plus 2 is a factor, our remainder darn well better be 0. We've made a mistake here. Let's drop our first one down. I've got 1. -2 times 1 is -2, so I have 4 when I add down. I've got -2 times 4, which is -8. So I've got 4 when I add down. -2 times 4 is -8. Yes, my remainder sure does end up being 0. Remember, when I'm dividing, now I have to drop the biggest exponent by 1 as I rewrite. So I've got x squared plus 4x plus 4. So right now, this is like this right now. We don't have this completely done. Now I can look, can I factor? Do I know what multiplies to 4 and adds to 4? Oh, I do. 2 again, 2 and 2, right? 2 and 2. This actually ends up being, when I factor this, x plus 2 times x plus 2 times x plus 2. Oh, this is a number 1. We had to do a number 1 with this one. That sounds silly to say. We had to do number 1. We had to factor this thing. And now that we've done it, this is like the same as x plus 2 cubed. So I have a triple root. Again, this acts like positive x cubed. And we've already seen that. We could see that right here, right? We can see it acts like positive x cubed. So I know I'm going to have my end behavior be down on the left and up on the right. And I know my solutions right here. X equals -2, and that's going to be a triple root. A triple root. So come over here to -2. Draw my point in here. Number 4, here's what's nice about this form. This makes the y-intercept really easy, because look what happens here. When I plug 0 in, this becomes 0. So 0 plus 0 plus 0 plus whatever your constant is. My y-intercept is right there. My y-intercept is 8. It's the only thing that doesn't get multiplied by 0. My y-intercept is 8. My end behavior is down on the left, up on the right, and it's a triple root. So it's going to do that kind of like inflection thing. And if I do this, this is a good example right here. That's 8. Why is that 8? Because that's what I wrote. I make my own axes. Why not? We can do that. But that's all we got to, that's what we're trying to get to with, right? You can see now the combination of all the polynomial stuff we've done in a question like this. Let me show you one more. Let me show you one more, right? I've got x cubed plus 4x squared minus 3x minus 18. X minus 2 is a factor. Okay, so we've already got x minus 2. So we need to do some synthetic division. We set that equal to 0. So x minus 2 equals 0. X equals 2. That's our first factor. So 2 is what goes in our house. Our coefficients are 1, 4, -3, -18. I didn't have to do anything goofy. I didn't have to put any zeros because we had all the terms in there. I drop the 1. Whoops, 1. Multiply by 2. Add down to get 6. 2 times 6 is 12. If I add down, I get 9. 2 times 9 is 18. And holy cow, I darn well better have gotten a remainder of 0, because if I didn't, I'd be in a lot of trouble, right? So if I got a factor and it's not a remainder of 0, it's not a factor, or I messed the math up. We drop the exponent 1 down, so I have x squared plus 6x plus 9 times our factor that we've already got, x minus 2. We can factor this. We know what multiplies to 9 and adds to 6. This becomes our number 1 here. We've got x plus 3 times x plus 3, or x plus 3 squared, times x minus 2. That's our factored form, right? I like this a lot, because in number 2, we can look at our end behavior. We go back to the beginning. This is x cubed. So I'm down on the left, up on the right, because it's positive x cubed. Number 3, our solutions in this case, I've got x equals -3, which is a double root. And 2, I can come over here and put these in, -3 and 2. Right? I'm going to bounce that off, -3. I can look right here, 0, 0, 0. My y-intercept is -18. So there we go. So however I draw this, my y-intercept better be below 0 here. So let's look. I'm going to bounce off this -3 because I'm starting from down here, right? Going to bounce off -3 because it's a double root. Come back towards the x-axis, go through my single root. Everything looks really good to me. I've got to bounce off my double, go through my single. My end behavior is down on the left, up on the right. Y-intercept is -15. I've done the things that I need to. All right, just like always, right? I've done 2 examples. I'm just looking for you to do 1. All right, so I'm going to hit pause. You're going to hit pause. We're going to give this a shot. See what you guys can do with it. All right, I hope this one brings a full circle for you. We've seen this one a couple times already. Right? The x cubed minus 2x squared minus 5x plus 6. We did that right on the front page. What I end up when I end up doing my synthetic division, I end up with x squared plus x minus 2 times x minus 3. That factors to x plus 2 times x minus 1 times x minus 3. That's my factored form. My end behavior is down on the left, up on the right. My solution, I'm sorry, my solutions or factors, or my x-intercepts are negative 2, 1, and 3, just like we had on the front page. My y-intercept is 6. It is positive. And because I can pick whatever I want on the y-axis, there we go. It's 6. All right. Is that a lot? Yeah, but it's not outside the realm of the things that we've done. We're combining all the stuff that we've done into one nice wrap up target. So with that said, we're good to go. We're going to get right on to the practice, knock some stuff out. If you got questions, ask them in class. Ask me, ask Mr. Gubino, ask anybody, email us, do what you got to do to understand this stuff. All right. Take care. Have a fantastic day.